In this video, we'll be looking at averages and spread. The first thing we'll look at are measures of central tendency. There are three. The first, the mean. The mean is often described as the average of the numbers in a data set. It is defined as the sum of the scores divided by the number of scores. The symbol for mean of a sample is x bar, while the population mean is represented by the symbol mu, one of the Greek letters. To calculate the mean, we add up all the scores in a data set, then divide this total by the frequency, the number of scores. The median is another measure of central tendency. It is the one way of describing a value that represents the middle or the center of a data set. The median, which kind of sounds like medium, is the middle score in a data set. The mode. The mode is another measure of central tendency. It's a third way of describing a value that represents the center of the data set. The mode describes the most frequently occurring score. Let's take a closer look at the median, because quite often this can be the hardest to find or calculate. If we have a set of data, they must first be placed in order. Here we have 8 data points: 1, 3, 4, 7, 11, 12, 14 and 19. The median is the middle value. So the median falls halfway between 7 and 11. So if we add these two together, 7 plus 11, we get, and divide by 2, we get 9. So the median is 9. We can then calculate the lower quartile, Q1. This is the median of the bottom half of the data set. So in this case, it is halfway between 3 and 4. So that would give us 3.5. And the upper quartile, Q3, is the median of the upper half of the data set. So in this case, it is halfway between 12 and 14. So in this case would be 13. If you have 9 pieces of data, as we have here, 8, 8, 10, 11, 13, 14, 18, 22 and 25, the median is actually going to be a piece of data, so that is 13, but Q1 and Q3 are going to fall between 2 pieces of data. Remember, Q1 is the median of the bottom half, and the bottom half doesn't include 13, so in this case it's halfway between 8 and 10, which equals 9, and Q3 is the median of the top half of the data set, not including 13, so that is going to be halfway between 18 and 22, which equals 20. If you have 10 pieces of data, as we have in this list, 12, 13, 14, 19, 19, 21, 22, 22, 28 and 30, Q1 and Q3 will be actual pieces of data in the set. So Q1 is 14, Q3 is actually a piece of data in the set, it's 22, but the median again, which is halfway between the data set, so it's halfway between 19 and 21, so the median in this case is equal to 20. The second thing we need to look at are measures of spread, how spread out our data set is. Interquartile range. Whilst the range is very simple to calculate, it is based on the sparse information provided by the upper and lower limits of the dataset. To get a better picture of the internal spread of a dataset, it is often more useful to find the set's quartiles from which the interquartile range, IQR, can be calculated. Then there is the standard deviation and variance. Standard deviation is a measure of spread, which helps give a meaningful estimate of the variability in a dataset. While the quartiles that we just looked at were related to the median central tendency, the standard deviation is instead related to the mean central tendency. A small standard deviation indicates that most scores are close to the mean, while a large standard deviation indicates that the scores are more spread out away from the mean value. Variance is the standard deviation squared. We can calculate the standard deviation for a population or a sample. In this course, we focus on the population standard deviation and variance. The symbols used are population standard deviation is equal to lowercase sigma, and population variance is lowercase sigma squared. Right, here is a question that involves everything that we have just really gone through. So I'm going to try and do as much of this as I can without a calculator. So let's start. A, find the mean. Well, the mean, x bar, which is equal to mu, is equal to, we add them all up, so it's 1 plus 4 plus 8 plus 8 plus 4 plus 12 plus 9 plus 7 plus 11 plus 8 plus 8 plus 3 divided by how many there are, and there are 2, 4, 6, 8, 10, 12 pieces of data, which is equal to 83 over 12, which is equal to 6.92. Part B is the median. So for the median, the first thing we have to do is put them in order. So the order is 1, 3, 4, 4, 7, 8, 8, 8, 8, 9, 11, and 12. So there are 12 pieces of data, so it is halfway between the 6th and the 7th, so the median is equal to 8 plus 8 over 2, which is 8. Part C, the mode. Well, the mode is just the most common, and if we look at the data set, the most common is 8, so the mode is equal to 8. Right, the range. Well, the range is just the largest minus the smallest. So that in this case is 12 minus 1, which is equal to 11. Part E, the lower quartile. Well, the lower quartile is the median of the lower half of the data set. So the lower half is 1, 3, 4, 4, 7, 8, and the median will be halfway between 4 and 4. So Q1 is equal to 4. Similarly, for Q3, I want the top half of the data set, so it's 8, 8, 8, 9, 11, 12, and again, Q3 is the median of this set of data, so it is halfway between 8 and 9, so Q3 is equal to 8 plus 9 over 2, which is 8.5. G, the interquartile range. IQR. Well, that is equal to Q3 minus Q1. So in this case, it is 8.5 minus 4, which is equal to 4.5. H, the standard deviation, and I, the variance. I'm going to use a calculator to do these, and I will also show you that you can actually find all the others using the calculator. So I've opened my TI Nspire at a lists and spreadsheet, and the first thing I need to do is put in my data. So I'm going to put it into column A. I'm going to call it X. The data doesn't have to be in order, but seeing as I've got it in order, I might as well put it in order. So 1, 3, 4, 4, 7, 8, 8, 8, 8, 9, 11, 12. So there's all my data. Now I go back up to the top of the spreadsheet. I'm going to highlight a spare cell. I've highlighted B1. Now I'm going to calculate all my things that I need. So menu, 4 statistics, 1 statistical calculations, 1 variable statistics. So I've only got 1 list, so to keep it as 1. OK. My list was called X. Everything else can remain the same. Press OK, and now it gives me a list of calculations. The top one, X bar, is my mean. Then it gives me the sum of all my X values, which I don't need at the moment. Then it gives me the sum of all my X squared values. Now it gives me 2 values for standard deviation. The top one, SX, we don't use. In the IB, we only use sigma X, which in this case is 3.14797, which is 3.15 to 3 significant figures. It tells me I've entered 12 pieces of data, then tells me that my minimum piece of data is equal to 1. My Q1 value is 4. My median value, or Q2, is 8. My upper quartile, Q3, is 8.5. And my maximum value is 12. My standard deviation, which is 3.14797, which is 3.15 to 3 significant figures, and my standard deviation, which is 3.14797 squared, which is equal to 9.91 to 3 significant figures. Question 1. The table below shows the distribution of deliveries made by a group of food delivery drivers on a working day in Berlin. A. Find 1. The median number of deliveries made. 2. The standard deviation. 3. The median. 4. The interquartile range. All these 4 can be found using a GDC. I've opened my TI Nspire to a data and spreadsheets page. I've already put in my data. In the first column I've put deliveries. In the second column I've put frequency. I've highlighted a spare cell, C1. So now I go to menu, 4 statistics, 1 statistical calculations, 1 variable statistics. I have only got 1 list. So 1 variable statistics, 1 list, OK. Now I called my list deliveries. I called my frequency table freak. Everything else can stay the same, so OK. And there are all my calculations done. There is my mean, x bar, which is 8.28. If I come down, there is my standard deviation, which is 1.34. Come down to my 5-number summary. So my median is at 9, and to get my interquartile range, I need Q1, which is 7, and Q3, which is 9. So if I now answer the questions, so A, which is the mean, x bar, is equal to 8.28. B, the standard deviation, is equal to 1.34. C, the median, which is equal to Q2, which is equal to 9. And D, the interquartile range, which is equal to Q3 minus Q1, which is equal to 9 minus 7, which is equal to 2. B, determine if a delivery driver who made 4 deliveries would be considered an outlier. Well, there are 2 definitions for an outlier. An outlier is lower than Q1 minus 1.5 times the interquartile range, or greater than Q3 plus 1.5 times the interquartile range. In this case, we will use the lower bound, so it is Q1 was 7, so it's 7 minus 1.5 times 2, which is equal to 4. So no is the answer. It is not. Anything less than 4 would be an outlier. The delivery drivers were selected for the survey by ordering their names alphabetically, then selecting every 20th number. C. Identify the sampling technique used for the sampling method. Well, that is systematic sampling.